Hello. Now, everyone knows what a 4G is, but what about the latest technology 5G? 5G is the fifth generation of cellular mobile communication. 5G is an evolution of existing 4G with lower latency, higher speed of communication, higher security concern, and better coverage. 5G is the latest form of cellular technology designed to increase the speed and responsiveness of wireless networks. 5G allows the use of device-to-device communication, which is a radio technology that allows devices to communicate directly with each other without going through network infrastructure such as base station, thereby allowing communication to be faster and more reliable. Therefore, it can be used in building cities resistant to natural disaster. In the event that network infrastructure is down, the device can still communicate with each other. 5G can reduce end-to-end delay in transmission to as low as 1 millisecond compared to 3G and 4G, which is at 40 to 60 milliseconds, which improves the latency. The air interface is defined as new radio. There are 5 technologies in 5G, and technologies are all being connected using backhaul link to the core network. Backhaul is a type of communication link between the global network and transport packet. The 5 technologies are millimeter wave, small cells, massive MIMO, beamforming, and full duplex. Millimeter wave is a band of spectrum between 30 GHz and 300 GHz. It can be used for high-speed wireless broadband communication. Millimeter wave is an undeveloped band of spectrum that can be used in a broad range of products and services like high-speed point-to-point wireless local area network and broadband access, which means more bandwidth available. Millimeter waves have short wavelength that range from 10 mm to 1 mm, and due to its short range of about a kilometer, millimeter wave travels by line of sight. They have high atmospheric attenuation, which means they are absorbed by gases in the atmosphere, which reduces the range and the strength of the waves. The things that can affect it are rain and humidity, which can impact the performance and reduce signal strength, a condition also known as rain fade. Due to its high frequency wavelength, it can be blocked by objects such as trees or even buildings. The problem of millimeter wave can be solved by small cell networks, which acts as relay to help transmit signal around objects that blocks its path. The small cell works in either licensed or unlicensed spectrum. Each small cell has a connection range between 10 meter to 2 km for a cell and can be distributed everywhere and interconnected to increase range capacity and improve the coverage. There are 3 types of cells, which are macro cell in a phone mobile network that provides radio coverage served by a high-powered cell site, a tower, antenna, or a mast. Microcell is a mobile network served by a low-power cellular base station covering a limited area and uses power to control or to limit the radius of its coverage area. Picocell is a small cellular base station typically covering a small area and used to extend coverage to indoor areas where outdoor signals do not reach well, or to add network capacity in areas with very dense phone usage. Massive MIMO, also known as massive multiple input multiple output, is a concept about providing multiple input and multiple output at the same time. The device will be able to share the same timing, frequencies, and resources together, which increases the network capacity. It also increases the spectral efficiency, where the rate of transmitting information can be increased without changing on the given bandwidth, which reduces the traffic intensity as more route is being provided for the data transmission, and the data do not need to wait at a single queue because it has more choices of route that can be used to transmit the data. Data capacity is being increased with more streams of data being transmitting from the base station to device. Massive amount of antenna elements is being used to support multiple users simultaneously and increase the throughput. Congestion occurs less frequently when there are more streams of data. There are more massive output choices to transmit the data. The data do not meet each other in their frequency and queue for a long period of time. Therefore, the queuing delay is reduced and the chance of packet loss are also reduced. Signal travels in multiple directions in vast amount and can interrupt each other and causes interference. Beamforming solves the interference problem of the massive MIMO by focusing the signal in a single target. Beamforming is a type of radio frequency management in which an access point uses multiple antennas to send out the same signals. It sends a focused stream of data to individual users, and the focused stream have less interference, which will also be more efficient. By sending out multiple signals and analyzing the feedback from clients, the wireless LAN infrastructure can adjust the signal strength it sends out and determine the best path the signal should take in order to reach a client device. In a sense, beamforming shapes the radio frequency beam as it travels the physical space of the enterprise. Full duplex data transmission means that data can be transmitted in both directions on a single carrier at the same time, and it also implies a bidirectional line, one that can move data in both directions. Currently, the base stations are half duplex, which means the data transmitted and received at the same frequency cannot be done at the same times. Otherwise, it will cause interference in the frequency. This will help to save time and could help to double the capacity of the wireless network.
Device-to-device communication. It is a concept about connecting device communication without going through layers of network infrastructure. It is connected through the small base station, which is built up by small cells. An access control by base stations will be acting as a protocol to control the air interface and schedule the uplink and downlink access of all devices. Device-to-device is done through directly, which is when both users are in line of sight, or through hopping when both users are not in line of sight. During natural disaster occurrence, normal network flashes and cloud increases and attenuations causes errors in packet sent. More severe disasters can cause damages to communication links and damage hubs and routers, which may be temporary or permanent. Also causes increase in traffic intensity in transmission links, causing network saturation. And this can be managed by using D2D communication in 5G network. In terms of medium access control, communication in D2D occurs between sender and receiver, where sender polls the receiver to check if there is connection. The receiver then polls back to the sender, and the sender then sends data packets containing data to the receiver. The receiver sends acknowledgement message for successful reception of message from sender. If the sender doesn't receive any acknowledgement message after polling to the receiver within fixed time frame, it triggers multi-hopping through relays, and the sender sends message to receiver through relays. One of the challenges that matter is peer discovery. User applications should be able to detect nearby peers fast and without high energy consumption. There are two types of peer discovery. Restricted, when you get permission to discover devices. Open, you can discover devices whenever in proximity, no need permission. In this case, peer discovery is controlled by base station, and in a multicellular network, it is very hard to get cooperation from nearby base station, causing peer discovery to be difficult. When it comes to energy efficiency, improvements in hardware efficiency play a significant role in increasing energy efficiency at device and infrastructure levels in mobile communications. However, incremental hardware advances will not reduce energy consumption sufficiently for 5G. Given the expected increased data rates, coverage, and number of devices. Thus, a major challenge is to use a software-based approach to improve overall network management. Current approaches to energy efficiency in mobile networks attempt to make the network smarter, and they fall broadly into three main categories: data rates, deployment, and renewables. Data rates work by energy efficient scheduling and power allocation in downlink of DMA networks with base station coordination across a range of maximum transmit powers show that relatively small reductions in the data rate resulted in significant energy savings. Results indicate that maximum energy efficiency approximately equates to maximizing spectral efficiency for low transmit power. However, this technique fails to provide latency, QoS, and data rate requirements for the 5G network. Deployment is by which cell wilting or sleep mode and cell blossoming or reawakening as a means to switch off and switch on subsets of base stations within a wider cell architecture. This technique also doesn't consider the latency or QoS and data rate requirements of the 5G network. Renewables, which is harvesting a combination of wind and solar energy to power individual base stations, is one of a number of renewable-related energy options for 5G. Similarly, optimizing circuit consumption, battery storage, and data rates while combining renewable and non-renewable energy sources are considered. Even though these techniques are important, they do not provide efficient flexible functionalities to the 5G network. Moving on to the energy efficiency architecture for 5G. One of the main requirements of the 5G technology is to provide energy-efficient resource management even with the high volume of users in the network. In this energy efficiency architecture, network resources in the data plane are dynamically adjusted based on the network information data processed in the control plane. This cognitive feedback system allows improvements in performance since machine learning-based predictive analysis alongside with the network policies in the control plane adjust precisely the data plane. In order to implement energy efficient systems in 5G, one must consider the insertion of such in the control plane. The control plane will provide both processing capabilities and important input information about the data plane. This is required to consider the current network state and its history for the machine learning predictive analysis. And also for any connective-based functionality, high performance energy efficiency can therefore be achieved due to near optimum resource management obtained from the connective-based system. An architecture was created to substantiate and validate the aforementioned idea. Traffic classifier. Current traffic passing through the network needs to be classified before a QoS class is attributed to it. The QoS class. A QoS class is attributed to the classified traffic and passed to the energy efficient protocol. In this way, the energy efficient protocol knows the data rate, latency, and QoS requirements of the application. Monitoring performance tool. The performance of the network is going to be monitored by some packet sniffing tool. Network configuration. Network configuration is going to be monitored. Whereas the Energy Efficient Protocol, or EE protocol, it commands the data plane with a network protocol that regulates energy usage in the network infrastructure, network interfaces, and network nodes, regulating messages with power in active modes, power in low power modes, and time in active modes can enhance energy policies performance in the network. Such information will be defined as a result of network information processing and predictive analysis. Information about the current network traffic, network history, and service layer agreements will help decision making of the energy efficient protocol. The EE protocol contains decision maker algorithm which is responsible for gathering all the data about the network and aligning with both the energy and performance demands. The output will be forwarded to the resource allocator. Resource allocation protocol, based on the resource setup given by the decision maker algorithm. The resource allocation protocol will transmit control information to the data plane to adjust the network configuration. The QoS class. Different applications will generate different traffic requirements that are translated into QoS classes. The decision maker algorithm needs to know which traffic is going through the network for setting up the required energy and performance demands by the application. Renewable energy. The decision maker algorithm needs information about the renewable energy resources available in the data plane network. This type of energy can be used depending on the QoS class and the energy saving demands. Resource allocation. The decision maker algorithm for overviewing different setup possibilities needs information about the current resource allocation of the data plane network. Network history profile. Periodic traffic traces collected for regular traffic analysis can be used to create a network history profile. This will allow the decision maker algorithm to conciliate the current network traffic with the regular traffic profile in the network in a given time. Predictive analysis. Because the control plane is located in high performance computing data centers, prediction algorithms can be used to quick analyze different options of resource allocation in the network. This will help the decision maker algorithm with choosing the best resources for the network and the applications running through it. And in the event of emergency policies influence the resource allocation of the data plane network for greater network management provisioning. So, to end this, what do you think about the energy efficient architecture? Is it efficient enough? And on the D2D communication, do you think it will be reliable? Let me know in the comments. And thank you for watching.